I welcome one and all for the next video. Today we'll be doing mat foundation for our project. So let's open the etabs file of the project. This is the etabs file where we have run the design of the model. After running the design, we get the window like this, where it gives the inertia at the top, inertia at the bottom, mid top, mid bottom, J and everything. So in this, first we'll have to find the dead load and live load falling on the columns in the story one or the base. For that, first we'll need to run the analysis and then the design, that is design concrete frames, view revise. After doing view revise preferences, then we'll have to go for start design check. Once the design is done, we have to verify whether all the members are passed. Here in our case, all the members are have passed already, so we'll be just looking at the dead load and live load falling on each and every column, the naming of all the columns and the size of all the columns. So first go to tables, then analysis results, then elements output, frame output, then element forces, right click and show tables. Okay, so once we get the table, we'll have to first go to story 1, then output case as dead. We won't be needing case type, step number or step label, so we'll go to format, filter, sort, format table. Here we'll deselect it, so case type, step number, step label not required, so okay. Now for each column there are 3 points, that is station 0, 1.225, 2.45. we want it at the base level, so we'll select 0. So for that, right click station, sort descending. So for each and every column there are 42 columns in our case, so C1 to C42 we'll get the p values. All are in negative, that means they are acting downwards. So these are the dead loads. For C1 it is 575.7 till C42, that is again 575.7. so this was about the dead load. Now for live load also we'll have to find out. So live load starts from 200.88 at C1 and it continues till again 200.88 for C42. so total for every column you will get dead load as well as live load. Now after finding dead load and live load, we'll have to find out what is the which are the columns C1, C2. We don't know that yet. So for that, what we can do is select the grid point, right click. In the geometry you will get this as C1. Similarly, go to this point, right click, C2. So we can see that each and every point, if we are going in this direction, that is 1 2 3, this is 4 5, this should be 4 5 6, again this should be 7. So we'll check once. This is 4, this is 5, 6, 7. So this so it moves in this way. This is C1 2 3 4 5 6, then again 7 to 12, 13 to 18. So once we know the alignment of the columns, I mean the numbering of the columns, it is important for us to know the uh, dimensions of each and every column. So for that, go to tables, go to design data, concrete frame design output, select the concrete frame summary data. In that, go to table concrete column design summary as per IS 456-2000. Right click and show table. Here also, go to story 1, select the station as 0 in the ascending order. So for every column C1 to C42, you will get the column size. So for C1 it's 550 by 550. It continues till C20, it's 550 by 550. Then for C21 and C22, it is 600 by 600. Then again it's the same, 550 by 550 for each and every column till C42. So till here it's the same. So there are total two types of columns, that is 550 by 550 and 600 by 600. So once we have made the list of dead load and live load coming on each and every column, we have also seen the numbering of the columns, how they are numbered and how they are placed in the uh, in the plan, and also we have seen the dimensions of the columns. So now we'll be opening the mat file, save file. We'll be doing the mat foundation. So here we can see this is the list of the dead load and live load which are applied on the columns at the base level, that is C1 to C42. So these every value we have to insert in the save file for each and every column. So once we have opened the save file, go to file, new model, the new model initialization tab will get opened. Here select the design code as per IS 456-2000. Units are currently metric. Then design preferences, in the design preferences go to minimum cover of slabs, change it to 50, and preferred bar size as you can select 20, 22 depending on your need. Now I'm selecting 20 here. Click on OK. Next, grid only. So as per the plan, this is 30 meters. Again, this is 30 meters. Let's assume that 2 meters offset is given on both this, on all the four sides. So total the size of our foundation slab becomes 34 by 34. So we can go for 2 meters of grid spacing. But here we can see that this is 5 meters. From here this is 5 meters, 10, 15, 20, like that. So doesn't matter even if we select 2, we can go always select the midpoint between the two grid lines. So that won't be an issue. So click on grid only. Total there are the size is 34 by 34. So the number of grids will be 18. And X direction 2 meters, Y direction also 2 meters. Click on OK. So the grid lines is formed. Now go to define materials. Here we'll be adding new material. For the foundation, since for the columns we have selected M40 grade concrete, here we'll be making use of M45. So M45 concrete, this is 25. The modulus of elasticity for M45 concrete will be 5000 root FCK, that is 5000 root 45, that is 33,541. So enter that value, 33,541. Next, the Poisson's ratio of concrete is 0.15. The coefficient of thermal expansion is 0.0000055. Next, the concrete cube compressive strength FCK is 45 Newton per meter square for M45 grade concrete. This is M45 done. Now add new material, that is the rebar we'll be doing. So rebar we are using HYSD FE 500. So rebar, now this is 77, this is 200,000. The minimum strength Fy is 500 and Fu is 545. So click on OK. So the two materials are defined now. Now go to define slab properties, add new property, slab 1, it's M45. Select a sufficient thickness. For example, here I am selecting 500 mm. In the later stage we will come to know whether this thickness is proper or even more thickness has to be provided. So for now, for the trial for the trial basis, we will be selecting 500 mm as the thickness. So click on OK. Slab 1 is done. Now for the columns, we'll be defining the column separately from column properties. Add new property, column 1, this is again M45. Here there are two types of columns, that is 550 by 550 and 600 by 600. Okay, so two columns are again selected. Now click on OK. Once the columns and the slabs are defined, we'll have to define the soil property. So here already by default a soil property is assigned. Let's assume that the soil subgrade modulus is 300 into 10 power 2 kilonewton per meter cube. So we'll go to modify, it's given 2, instead of 2 it will be 3. You can also change the name. For example, you can just name it as soil. Non-linear option, for non-linear cases it should be compression only. So click on OK. Soil is also defined. Now go to load patterns. Dead and live load are already assumed. For dead load, self-weight multiplier is 1. OK. For load cases, linear static, because we are considering the linear static case type. So click on OK. Again go to define load combinations. Here we'll have to add two load combinations. So add new combo 1, linear addition, dead and live load with a scale factor of 1.5 each. So this is for strength ultimate. Click on OK. Next, again the scale factor should be 1, and this is designed for service initial, service long term and service normal. So click on OK. Now the load combinations are defined. Click on OK. So in the define, we have defined the materials, the slab properties, column properties, soil subgrade properties. We have seen the load patterns, load cases, and also we have given two load combinations. So once the defining is done, you have to draw. So starting with draw slabs areas. So the total size of our foundation slab is 34 by 34. Here we can see, as we had selected 18 grid lines, here we can see that it is 34 meters. So once the slab is drawn, make sure that the property which you have selected is slab. Close. Now draw columns. In this, make sure that the properties which you are selecting is proper, and property below should be none, because the columns are not below the slab, they are above. So property above is column 1. Height below is 0, and height above we are considering as 2 meters up to the plinth level. So once this is done, column 1 is at every 5 meters distance. So 1, you can always zoom the slab for your convenience. So this is 1 after 5 meters, second after 5 meters, third, so as you can see there are total 7 columns in one row. Now the spacing here is 6 meters. Now here the column size is 600 by 600, that is the 21st column, 21st column and 22nd column. So here the column 1 won't come, so directly here again always make sure that you are selecting the proper points, or else there will be a huge problem in the later stage. So once the column 1 is assigned, right click, click on close, then escape. Now draw columns, column 2 this time, and place them properly. One is here and the other one is here. So once this is done, click on escape. So the columns are placed. Now we'll be designing the design strips. So the formula for the design strips is 0.25 times L1 or L2. In our case, L1 and L2 both are 34 meters. So 0.25 times 34 meters is 8.5 meters. So go to draw, design strips, select, give proper definitions, that is dimensions, that is 8.5, 8.5. So once this is done, select the center line of the column, and this is in layer 1. Then right click, layer 1 or X direction is one and the same thing. Now in the y direction, so layer B. So once the design strips are drawn, you can always go to the set display options, design strip objects, to see the width of the design strips. So click on OK. You will get something like this. So go to the set display options again and deselect the options, click on OK. Now once the design strips are drawn, it is important to assign the values to the assign the reinforcement values to the slab, the columns, as well as the design strips. So first we'll be doing for the slab. Click on the slab. Here on the left hand side bottom, you can see that one area 4 edges is selected, that is slab is selected. Now right click, go to design, rebar material as HYSD FE500. Similarly do it for all the columns and the design strips as well. Once for the design strips the rebar material is defined or assigned, for columns it is important that you select it properly. That is, don't select the center point of the column, just select the column that one area 4 edges is selected. Then right click, it's already HYSD 500. Similarly check for all the columns, it will be HYSD FE 500. Zoom as per your convenience. Okay. So here we can see, we can see, that for every column the rebar material that is selected is HYSD FE 500. When you are assigning the load, make sure that you have selected the center point of the column. Then go to assign, there select the center point, go to assign, load data, point loads, here the value, then the size of load for punching shear will be the size of the column, that is 550 by 550. Add to existing loads or replace, you can, it is better to go for replace existing loads. Click on OK. Once that is assigned, go to the second point, go to assign, load data, point loads. This time the value is 2275. Okay, do it for all the 42 columns for the dead load and the live load respectively. So once the dead load and the live load are assigned, you can see only the live load or the point loads which are live load are only mentioned here, because it gives only one type of force in the window. If you right click on any one of the column, then you can see that the dead load 1173 and live load 414 are being assigned. So similarly, for all the 42 columns are the dead and the live load are been assigned. Care should be taken while assigning the dead load and the live load for column 21 and 22, because the column size is 600. So here you can see the load size and the column size have to be same, 600 by 600, 600 by 600. For rest other columns, the load size is 550 by 550. So once the load is assigned, select the slab, select the slab, that is one area as 4 edges selected, assign, go to support data, soil properties, soil, click on OK. So the soil is selected. Now again select the slab, right click the slab, assignments, see the slab property is slab 1, that is the footing. Okay, for the columns it will be taken as column 1 and column 2. For example, if I select one column, go to assignments, it will be column 1, because so once the soil is assigned, load data is assigned. Now the assigning part is done. Now go to run analysis. If a proper name is not given to the file, then give a proper name. Save. Then it will save the model, then it will run the analysis. Wait for the analysis. Once the analysis is done, you can see the displacement values for in in this lab. So here you can see either you can move your cursor and see the deflection values, or else you can also see the range of the deflection values from the right hand side through the scale. This deflection values is for the dead load, as mentioned here, deformed shape displacements for dead in You can select the right arrow key to go for the live load, to check the displacements for the live load. Again here you can see the values, or else you can go to display, show deformed shape. Here you can select the load case as live or dead, load combinations as combo 1 or combo 2. Let us select the first combination 1, apply. So you'll get the deformed shape for the combination 1. The maximum deformation is about 19.5 mm. Click on close. Now go to run analysis and design. Once the design is done, go to the display, show punching shear design. Here you can see the values of the punching is more than 1. That means that the slab, the foundation slab or the foundation as whole is failing. For every column, except for the corner columns, the value is more than 1. So we'll have to redesign. The redesigning is done by increasing the slab thickness. So first unlock the model. From unlocking the model, it will only delete the analysis and design results. Rest all the load assigned, all the properties remain the same. So go to define slab properties, modify or show property. The thickness which we had selected earlier was 500. Now make it 1250 mm. Click on OK. OK. Now run analysis once again. Wait for the analysis to be run. Once the analysis is complete, go for run analysis and design. Once the analysis and design is done, again go to display, show punching. Now you can see that the punching shear values are less than 1. You can even reduce the slab thickness so that the foundation becomes more economical. In our case, we'll just keep it to here. Now we need to once the punching shear is done, we can see the reaction forces. Dead, live, or load combination. We can do anything. The values fz or fy or mz, we can find see the values. Then go to display once again, show slab forces or stresses. Here you can select F11 or M max and select the load cases for dead or live load combinations as well. Again go to display, show strip forces. Here for the strips in the layer A or layer B, you will get the values for moment and shear for load combinations or load cases. So for load case dead, let's take shear, example of shear force for the layer A. Apply. You will get the values. If you move your cursor, you will get the values of the shear forces at each and every point. For layer B also you can get the values like this. This was for the dead load. For the load combination also you can get this is the shear force value. Now the moment values, these are the moment values. For layer A also you can get similarly. After the strip forces, you can go for the slab design. In the slab design, always select the impose minimum reinforcing. For layer A, apply. Here you can get the reinforcement values in the top and the bottom side. Similarly for layer B can be obtained. Now go to display, show crack width. Let's go for the load combination com1 and slab bottom face apply. It will show the crack width, the width of the cracks that might occur due to the load. So these are the number of cracks which can occur. The crack width is less than 1 mm. Here you can see from the color chart. So the maximum being 0.65 mm. So that's not a big issue. At the top face also you can find top face also maximum is 260 mm, 260 into 10 power minus 3 mm. So once this is done, go to run detailing. Okay, wait for the detailing. Once the detailing is done, go to the drawing component views, go to the slab views. Here you can see the framing plan, rebar table, where the bar mark, diameter, shape code, cut length, numbers of bars, total length in meters is given. Rebar schedule can also be obtained. So this is the rebar schedule for members, bar mark, and every other properties is mentioned. Bill of quantities can also be generated. This is the bill of the quantities. In the individual slab views, slab 1, you can go for rebar plan, top rebar plan, bottom rebar. So you can select any of the you can double click any of the plan or any of the layer profile, and you can get the drawings for the same. Also in the drawing sheets, you can go for general notes, list of drawings, general notes, rebar shape codes, etc. So this was the video about the slab matte foundation design. Thank you very much for the patience. That's it. Thank you very much.